Welcome to Year 1, Pure 1, Chapter 12.2, where we look at differentiation by first principles. Now, if you're watching this video after 12.1, then you should turn around and come back to it after you finish the whole Chapter 12 and leave it till the end. Because this first principle method actually has nothing to do with the rest of the differentiation chapter. Now, and this has to be taught because whatever you've learned previously about differentiation, okay, the method where you multiply by the power and then power minus one, that's actually a shortcut. First principle is where the ancient method of differentiation, the OG of differentiation, okay, which will be asked in the examination, in the exam, where they ask you, okay, can you differentiate by first principle? So they will say by first principle, okay, that's why you have to use by first principle. Now, before we start, okay, here's some starter question about substitution, because the first principle essentially is just a big formula which you need to do a lot of substitution, similar substitution. So I'm going to ask you, pause video, have a go at this substitution question, okay? Question 1 to 3, your answer will be numerical, okay? But question 4, your answer will be an expression, algebraic expression. Okay, pause video, have a go at starter question. When you're ready for the answer, you can press play. Here are the answers. Okay, question 1, 25. Question 2, minus 5. Question 3, 4. Question 4, substitute x plus h into x. So you will square the bracket first before you times it by 2. One thing to note is on the left-hand side, I put f of 5, f of minus 3. So note this kind of notation. We're going to use it later. Okay, so when you sub it in the x value, the bracket in the f of x becomes the value itself, right? So next, a bit of theory, okay, about what is first principle. So background, okay, as we know, differentiation helps us to find a gradient function and hence calculate the gradient. The gradient function, also known as a derivative, okay, about a certain point of the graph of the curve. So differentiation helps us to find a gradient on a certain point of the curve. Okay, this method is also known as, there's also a method called differentiation by first principle, derived by two very famous mathematicians, Isaac Newton, who is English, and Gottfried Leibniz. He is he's not a mathematician you would have heard about in GCSE or primary school maths, object A-level maths, but you will hear him a lot if you do anything higher than A-level, probably university. Okay, Leibniz. He gave me absolute nightmare when I was in uni. I think he might be a German or Swiss or Austrian, one of them area. It looks like German to me. The shortcut we learn about differentiation, where you multiply by power and then power minus 1, is derived from first principle. Again, the OG of differentiation. Okay, so here's a theory part. The main premise of the first principle, okay, is that, say we want to find a gradient function or derivative of a point on a curve. Okay, so y equals f of x. And let this point to be x f of x. So what I'm trying to show you is, okay, so that's a curve, okay, like a hairline, but actually that's a curve, okay? And we want to find a gradient of this part, okay? So the gradient of this part. So we're going to find a gradient, okay? So we want to find tangent. So we want to find tangent at this part, okay? And then in GCSE, you will learn about drawing a right angle triangle in here, right? But we're not doing that, okay, right now. What we're going to do next is, okay, let this point to be x f of x. So now, if I'm zooming in this part, okay, 100 million times. So if we draw the tangent line, I'll explain the x f of x part later on. Again, this theory, all this kind of theory, you don't have to remember it or understand it, okay? You don't have to prove it, all right? But I'm trying to show you where did it come from, where did the formula come from. If we draw the tangent line extremely small, okay, imagine we zoom in a curve using a microscope, then that part of the curve will become an almost straight line, okay? So if you zoom in a million times, no matter how curvy the line is, okay, it will almost become a straight line, okay? So this line, okay, this point x f of x, okay, so this point, okay, x f of x is a coordinates, okay? I'm just going to put it here, okay? So there's the point, okay? So x f of x, all right? So x f of x at this here, all right? This point, x f of x. Now, I'll explain what the hell is x f of x. Okay, in a traditional coordinates x, y, right? Okay, and then x and y. you're told y is f of x. So if I substitute y is f of x, then you get x, f of x and f of x. So let me get rid of this. Okay. So what am I doing? Well, I know. So I know y equals f of x, right? So therefore, replace y as f of x, so x f of x. It's a weird kind of coordinate, but you see this kind of generalization when we talk about theories in maths, right? Which is quite common in high level of maths. So x f of x. Okay. Now we're trying to find the tangent, okay, like a normal straight line. All right. So I'm going to call it another point. Okay. Let's call this point. Okay, in here. Now what I'm going to do is, okay, I'm going to draw a right angle triangle. Okay. Oops. Two. No, in here, right angle triangle. Okay. Now I'm going to call this distance h. Okay. Then now, can you try to tell me, okay, what is the coordinates of the new point? A tricky question. Okay, it will be in algebra. Okay, think about the x value first. So you've got x in here, and then you move to right by h. So it'll be x plus h for the x coordinate, right? What about the y? Now, x f of x, right? So if x is x, then the y will be f of x. If x is x plus h, then the y will be f of x plus h. Hence, what you've done in the start of the question about x plus h in here. Okay, same thing. All right. So how do you work with the gradient? All right. So the gradient will be roughly equals to the difference in y. Okay. So difference in y. So think about what's the difference in y. It will be f of, so it'll be, I'll put in here, difference in y over difference in x, which is f of x plus h minus f of x, which is difference in y, okay, over difference in x plus h minus x. If I simplify denominator a little bit, it will be f of x plus h minus f of x over h. And in fact, this formula that we found in here, okay, is the core of the first principle formula. So, oops, differentiation by first principle formula. Okay, given y equals f of x, then f dash x equals to limit. Okay, sorry, limit lim h tends to 0, and in the formula where you got f of x plus h minus f of x all over h. This is given in the formula booklet. Okay, so you don't have to remember it, right? Now, limit h tends to 0, this part means h is a limiting value to 0. Now, what does that mean? Well, mathematically, okay, mathematically means we substitute h being 0, okay? But why is h tend to 0? Okay, now back to theory. Again, all of these theory, all of this understanding, this part of the whole thing, you don't have to remember any of them, but it's just to show you, okay, where first principle come from. First principle come from finding the tangent of any certain point on a curve. And what we do is we zoom in a million times, and that curve becomes a normal straight line. And then we assume that coordinates x f of x, and then we just say, okay, now remember, because this point has been zoomed in a million times, that means these 2 points, x f of x and x plus h, f of x plus h, even though they seem quite far apart on the line, but technically on the curve, they're very, 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 very close because we're zooming a million times, right? So that distance here, okay, that distance, we call it h. Because we've been zooming a million times, that h value, to be honest, is a very, very small number because they're very, very close to each other. So therefore, okay, we say h is a number that close to 0, but it's not 10 to 0. H is a limiting value to 0, means h is a value that is very, very, very close to 0. So you can think about not point, no, 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 not 1. All right. So, I'll put in here. Okay, why is that the case? H is limiting. Okay, it's limiting to 0 because the tangent is extremely small. I don't know why I write like this. Such ugly writing. Extremely small. Okay. Right. So here's the formula. Right. So the next part of the lesson is where I'm going to show you how to use the formula. Okay. I have I have a structure that I like students to write it. And that helps you to eliminate some silly mistakes. Right. So here we go. Okay. Here's the formula. I put it on top so you can refer back to it. Example, differentiate y equals x squared using first principle. You will see this using first principle in exam. When you see this, that means you have to use this formula. Okay, so what I'm going to do is, if you look at this formula, it consists of three parts: the f of x plus h, the f of x, and the h, a limit sort of thing. Okay, so what I'm going to ask you to do is, okay, we're going to write f of x. You always say it up like this. Okay, do me a favor. Okay, when you say first principle, say it up like this: write f of x, write f of x plus h. So what's f of x? F of x is just x squared. What about f of x plus h? Is when we substitute x with x plus h. So any x that you see, you substitute with x plus h. So x plus h squared. And you do your simplification here. Expand the bracket and just make it as long as possible so you can sub it in later easier. So you're doing yourself a favor for future. So expand the bracket. So x squared plus 2xh plus h squared. Now, then we use the formula. Okay, so then the third step will be f dash x. Okay, copy the formula, limit h tends to 0. Okay, now the formula tells me to do f of x plus h, which is the second part. So I'm going to copy this one in. So x squared plus 2xh plus h squared minus f of x. Oops. Minus f of x. So f of x is x squared. Now, when you put a minus, do a bracket. Because when this equation has more than one terms, your minus will change all the signs in the bracket. So just be careful with that. So put a bracket. And then over h. All right? Now, remember I said about limit h tends to 0. What does it do mathematically? Substitute h equals 0. The limit h tends to 0 means we substitute h equals 0. But you realize there's a problem when we sub in h equals 0 in this case. If we sub in h equals 0, h squared, nothing happened. But denominator, when you sub in 0, what happened? When you have a denominator over 0, you get a maths error. That's undefined. So that's why you can't do it yet. Okay, so you have to keep writing the limit h tends to 0 until you can substitute the h equals 0. Okay, so I'm going to keep writing it. Okay, so f dash x equals limit h tends to 0. Okay, simplify the numerator. So x squared minus x squared, that's gone. And then nothing else we could do. So numerator 2xh plus h squared over h. In the numerator, I'm going to factorize the h out. Keep writing it. So 2x plus h over h. Now these two h cancel out. So I get f dash x equals limit h tends to 0, 2x plus h. Now the denominator h is gone. Can we now substitute h equals 0? Yes, we can. So we substitute h equals 0. So f dash x equal 2x plus 0, which equals to 2x. F dash x equals 2x. So in here, what have we done? We just substitute h equals 0. So as soon as we did the substituting, then we can stop writing the limit. Otherwise, keep writing it. So how to verify your answer? Very simple. Use a shortcut. Differentiate x squared, which is 2x. Differentiate manually, 2x. And we got 2x. Okay? Here's a practice question for you. Okay? Prove by using first principle the derivative of f of x is 4x squared is 8x. So here's a formula. Okay? So before we start, I'm going to start you off with this format. So do f of x equal f of x plus h equal, and then f dash x, use the formula. Okay, so limit h tends to 0, and I'll let you write the fraction. Right? Pause the video, have a go at the question. When you're ready for the answer, you can press play. So here's the answer so far. I'm going to show you how I set it up. So before you got it wrong, you've got another chance to pause the video and have a go again. So f of x is 4x. Oh, I made a mistake. Let me fix it. Ha, silly me. Anyway, I've got the x squared. Anyway, so I fixed it. Hopefully, you should see in here. Actually, let me color code this as well. Okay, so put it in. Okay, hopefully you've got this step right. All right, don't be like me, make silly mistakes. And then yeah, if you got this right, carry on. So what I'll do next is I'll just show you how to finish off. So limit h tends to 0. Again, simplify 4x squared and x squared is cancel out. So I got 8xh plus 4x squared. I'm going to factorize the h. So 8x plus 4h over h. Cancel out the h. Now, some of you asking, okay, what about a 4? Do you have to factorize the 4? It doesn't matter. Okay, if you want to factorize the 4, you can, but factorizing 4 doesn't do us any favor in here. What we need to do essentially is to cancel the h. That's why I want to factorize the h. So I got ax plus h. I sub in the h equals 0 because now the denominator h is gone. I have no issue substituting h equals 0. So f dash x equals 8x plus 4 times 0, which is 8x. Done. All right. Another one. Right? Example. This time, it's just a longer version. F of x is slightly harder. 4x squared minus 3x plus 5. So again, same thing. Set it up. So f of x being 4x squared minus 3x plus 5. F dash, not f dash x. F of x plus h, okay, being substituting, okay, x plus h squared minus 3x plus h plus 5. Now this time there are two x's, one in the 4x squared, one in the 3x. Substitute x plus h into both of them, okay, and then expand bracket and simplify everything. So I'm going to expand bracket in here. X plus h squared is x squared plus 2xh plus h squared. Expand the minus 3 be minus 3x minus 3h plus 5. And then do that. So expand bracket 4x squared plus 8xh plus 4h squared minus 3x minus 3h plus 5. But my writing, that's very ugly. I keep apologizing in this video. I don't know why. So anything I can simplify? Not really. So I leave it like this. Okay. Next step, I can use a formula. So f dash x equal limit h tends to 0. Okay. The big fraction. So I'm going to put it f of x plus h first. So 4x squared plus 8xh plus 4h squared minus 3x minus 3h plus 5. Subtract a bracket of f of x. Put in the f of x in there. Guys, put it in here. So it becomes 4x squared minus 3x plus 5 all over h. Okay, so now limit h tends to 0. So let me write fraction all over h. So I know, okay, doing some mental maths, okay, simplifying 4x squared, that's a minus 4x squared, so that's gone. Okay, minus 3x becomes a plus 3x. Minus 3x and a plus 3x, gone. Minus positive 5 becomes minus 5. 5 minus 5 is gone. Right? So you will see what I'm left with is 8xh plus 4h squared minus 3h. Factorize the h, do the same thing. 8x plus 4h minus 3 all over h. Yay, cancel out. So I can sub in h equals 0. Okay, so 8x plus 4 times 0 minus 3, which is 8x minus 3. And that's finished. So that's f dash x. That's the derivative. Again, how do you verify your answer? Just use the shortcut. Differentiate 4x squared, 8x minus 3x minus 3. 8x minus 3, yeah. Okay. If you're happy with this, your turn. Okay. This time, I'm not going to help you set up anything. You should have seen my 2 examples. You should be able to, and you've done one practice question. So pause the video, have a go with the question. Okay. When you're ready, I'm going to show you the workout up to the up to the formula step. Okay, so setting up the beginning and up to this step, up to the formula step. Okay, pause video, do up to that step, or if you want to finish the whole thing, do that. And when you're ready for the answer, you can press play. So here's the answer so far, where f of x is x squared plus 3x, f of x plus h is substitute x plus h into squared, and then the 3x plus h as well, expand everything, and then put in the formula f of x plus h go first, minus f of x. All right? Then in here, you can then keep going. You've got the rest right. Okay. I'm not going to show you anything else. So finish up the question, and I'll show you the rest of the answer. Here's the final answer. Okay, here's the final answer. Um, simplify the x squared, and the 3x is gone. Then you've got the h terms, factorize the h, divide with the denominator, and then substitute the limit, h equals 0 in there, and you can stop writing the limit. So 2x plus 3. And in the final line, don't forget to write f dash x. Right? Yep. Now, if, okay, you're looking for a challenge, you can have a go at this question. Okay. This is quite a challenging algebraically. Using algebra skills is quite a challenging question. If you're up for a challenge, you can pause the video, have a go at the question. I'm going to show you the working out. I'll show you the answer. I'm not going to go through any more than that. But if will I expect this kind of question to appear in a real exam? Probably not, because if they do, it's going to be a lot of marks dedicated to this question, and I don't think they want to waste the marks on these kind of question for the first principle. But if you're interested for a challenge, okay, have a go, pause video, and have a go at the question. But if you're not interested in the challenge, okay, that's it for me. First principle is enough. Then that's it. End of lesson for you. Okay. So pause video, have a go at the question. When you're ready for the answer, you can press play. So this is step up to the formula step so far. You can check your answer before moving on. Okay, especially with the minus in the bracket. Right, so I'm going to show you just the final answer is x squared plus 1 over x squared. Okay, so I did a double check as well to differentiate the original using the shortcut, and I got the same answer. Okay, minus 1, minus, right, hang on. Oh, did I messed up? Was it x minus? Oh, I messed up somewhere. Be right back. Let me find my mistake. Actually, the silly mistake is in the part where I actually did double check. When I did a minus one, when I multiply minus one by the minus, should be positive. Anyway, so it should work. Okay, it is work. Okay, it is correct. Okay, so my working out in green is correct. Right, so where were we? Okay, so previously, I showed you the up to this step. Okay, so what I did next was I just multiplied, put in a negative into the bracket. Right, so minus x plus 1 over x and minus x cancel out. So I rewrite this. So h minus 1 over x plus h plus 1 over x over h. Now this part is a bit tricky because you've got fraction, which is you got fraction on a fraction. On the numerator, you've got some terms which are fractions, some are not. To simplify these kind of complicated fractions where you have some parts that's fractions, some parts that are not a fraction, the best thing to do is to have a common denominator and simplify it. Okay, so what I did was now in the all over h, I didn't do anything. So you can see the big fraction line over h, big fraction line, h is in there. What I did in numerator was that I have a common denominator. I'll show you what I mean by that. So I want to show you, okay, so it's h over 1 minus 1 over x plus h plus 1 over x. Then for the common denominator will be, if you multiply all of them, it will be x times x plus h. So for the first fraction, you can see to get 1 to x and x plus h, I need to multiply h by x plus h. For second term, if I have to multiply to get a common denominator, I need to multiply by x. For the first fraction, I need to multiply this by x plus h. If you struggle to understand this, think about this. Okay, think about I have 2, okay, plus 1 over 3 plus 1 over 5. Actually, let me make it into minus so it looks similar. Okay, the common denominator will become 1 times 3 times 5, which is 1 times 3 times 5, which is 15, right? Common denominator. So to do this, I'll do 2 times 15. This one, I'll multiply second one by 5, and the third one, I'll multiply by 3. So it's just simplifying fractions. So in here, that's how I got this step. What I did next is then now denominator x and x plus h all over h. So I expand the bracket x and x squared, x and h, xh all over h. Numerator, do the same thing, expand the bracket, hx times x, hx squared, hx times h squared x minus x plus h. Next, I also cancel out the minus x and the x. Then once I've got a big fraction over a fraction, it's time to get rid of one of the fractions, which is the big denominator. So write the divide over h as divide by h. Divide by h is same as multiply by 1 over h. Keep flip change. Think about when you divide a number. Okay, divide a number means you multiply by 1 over. So multiply that by 1 over h, which is same as h times x squared plus xh. I'll show you what I mean by here. For example, e.g. in here, if I have 1 over 3 divided by 4, that's the same as 1 over 3 times 1 over 4, which is same as 1 over 3 times 4. Okay, same thing in here. 1 over 3 divided by 4 is same as 1 over 3 times 1 over 4. Okay, so h times x squared plus xh. Up to this step, then I factorize the h in numerator. I cancel off the h in denominator. So I've got x squared plus hx plus 1 over x squared plus xh. Finally, I can substitute h equals 0 into the expressions x squared plus 1 over x squared plus 0x. Then I got this term. Now again, do I see this in your exam? Probably not, but it's a very good practice on the algebra side. Okay, and that's the end of the differentiation chapter.